Okay. Hi, today we'll be presenting our OOP Java assignment, which is Climate Application, and we are from Section 3, Group 7. Our team have two members, and I'm Gaudzini.
And I'm Masha Chan.
So, the main goal of our app is to educate users about the climate change by offering four interactive features, which is a real climate data analyzer, a climate knowledge quiz, and a personal carbon footprint calculator, and also a sustainability action recommender. Then, I personally work on the first two modules, which is the climate data analyzer and the climate change quiz. Let me walk you through both. For the first module, climate data analyzer, this module allows users to explore real climate data from the year 2000 to 2024. When users launch the module, they can choose a country from the menu like India, Brazil, or China. Then they can select a climate indicator they want to analyze, such as sea level rise, CO2 emissions, temperature, and extreme weather events. Then the system will calculate the average value across all years for that country, and based on data stored in a CSV file called Climate Disasters Data, where we import from the platform Kaggle. So, if a user selects India and then choose to know the view the CO2 emissions data, then they will instantly see the average CO2 tons per capita for India from 2000 to 2024 based on the data we import from Kaggle. So, this promotes awareness through interactive data exploration. Move on to the second module. The second module I handle is a 15-question interactive objective quiz designed to test users' climate knowledge. So the questions are randomized for each session with four options. Then user can also choose to quit anytime by typing X. As user progress, the program gives feedback on whether their answer is right or wrong. So to make it fun and engaging, we also include a level up system so that uh, users are more encouraging to use our quiz. This module is especially useful for educational purpose as it helps raise awareness in an interactive and enjoyable way. At the end of the quiz, it can also export the results to the text file with timestamp. This supports the climate education in a more fun and interactive way. So those were the two modules I work on, the climate data analyzer and the climate change quiz. I'm Zuni, and now I'll be passing it over to my teammate, Marsha Chan, who will explain the remaining modules, which is the carbon footprint calculator and the action recommender.
Thank you, Zuni. Now I'll be talking about the next two module, which is carbon footprint calculator and action recommendation. A carbon footprint calculator is a powerful tool designed to estimate an individual's or a household carbon emission based on their everyday habits. By analyzing key lifestyle areas such as transportation, home energy usage, food choices, general consumption patterns, and shopping, as well as waste products. The calculator provides users with a clear picture of their environmental impact with such simple and user-friendly inputs and real-time results displayed in kilogram carbon dioxide per year. Users can quickly understand how their daily decisions contribute to their overall carbon footprint. This immediate feedback empowers people to take ownership of their role in climate change and be more mindful of their lifetime choices, and also help users to reflect on their personal impact of carbon dioxide. Next module is is an action recommender. Action recommender builds awareness. The tool offers actionable recommendations tailored to the user's habit or quiz results. This suggestion may range from reducing meat consumption and using public transportation to switching a renewable energy sources or minimizing single-use plastics. Whether randomized or behavior-based, each recommendation reinforce positive climate habits and encourage incremental, sustainable changes in their daily life. By helping users reflect on their impact and offering realistic, eco-friendly alternatives, the tools serve as both a motivator and a guide on a journey towards a more sustainable future, like and a more sustainable lifestyle. Thank you. I'm Marsha Chan.
Then moving on, we will be moving on to the demonstration of the 4 modules in our climate application. So, hi, I'm Zini, and now we'll be demonstrating the climate app. First, we have to run this main class. And as you can see, when we run the main class is for the climate app, and it shows the climate app menu for the 4 core modules of this climate app. As you can see, for my part, I'm doing the climate data analyzer and climate change quiz. So in climate data analyzer, I've separate it into 4 different class. The main class is to run the climate data analyzer, and then for the importer class is to import the CSV file I've downloaded from the platform Kaggle into this Java program. Then for the country country class. This country class is to store the country list, which import from the CSV file. And we are using #set because there are many duplicate country names in the CSV file dataset. So we have to use a #set to check if there's no to avoid the duplicate country names, and then we add the new country names into the country list so that there will be no duplicate country names in the final menu option. Then for the indicator class, this is to display the indicator menu after user have chose their country they want to view. So it also calculate the average indicator data from 2000 to 2024. That's all for explaining the class. Then now I'll be running this climate data analyzer. So to use this, we are going to enter the option 1. After we run the climate data analyzer, then it will show how many records we have loaded from the CSV file. Then this will show the country menu in the climate data analyzer, and then we can choose which country we want to view its climate indicator data. For example, if I want to view the data for Canada, then I can enter the option 3. So this shows the country we have chose, and then these are the indicator menu that we can choose to view. For example, if I want to view the CO2 emissions data, then I'll be choosing the option 2. And then this shows the average data for the CO2 emissions, which is 15.4 tons. And then it will be looping back to this indicator menu, and we can choose other indicator data that we want to view. For example, I want to view rainfall, then I'll choose option 4. And then this will be the average data we have calculated in the indicator class. And then it will also loop back to the indicator menu after it shows the output. So it will be same for the other indicator data. So if we're done viewing this the indicator data for this country, then we can enter the option 6 to go back to the country menu. Then let's try another countries. For example, I'll try Japan. Then I'll be entering the option 10. Then it also the same. We can choose which indicator data we want to view. For example, I want to view the rainfall. Then I'll enter the option 4. And again, it shows the average data for rainfall. Option 5, the average data for the extreme events. Then, if we enter the option that are out of the range, like for example, I entered 9 that are not in this range, it's only 1 to 6, but I entered 9, then it will be showing an error message, and then loop back to this indicator menu to let users choose a valid option. Then, if I want to go back to the country menu, option 6, the same goes with the country menu. If we entered output that are option that are out of the range, the highest is 20, and then I've entered 25. Again, it will be showing error message and also looping back to this country menu for users to choose a valid country option. So this will be the end of the demonstration of the climate data analyzer. Then I'll be entering option 20 to exit this module. After exiting this module, it will loop back to this app climate app menu, and so we can choose to use other modules. Then moving on, I'll be explaining the another module that I'm in charge of, which is the climate change quiz. So as you can see for this quiz, I've separate this quiz into 3 different class. The main class is to run the whole quiz, and then this class question answer is to store the questions, the options, and also the answers. For the exporter, this quiz can export the quiz result into this txt file, also with the timestamps and status and the final score. We have used this IO exception as a exception handling to to show if it is okay to working writing to the txt file. If not, then it will show error message. It is input output exception. So we have done explaining, then we'll be start demonstrating the quiz. I'll be choosing the option 2 to use this quiz. Then it start showing these questions, and these 15 questions are randomized by by using the random class here. So every time the users take the quiz, then it is in the randomized question order. Then we will start. It gives us the option A, B, C, D, or X to quit. So this is the question and this is the option. And after user know the question and the answers, then it can enter the option A or B or C or D to answer the question. Enter A. So if we are correct, then it will show the correct message. And move on to the next question. And the score will be added 1. Then for question 2, if we answered wrongly, then it will show the incorrect message and also shows the correct answer, so that the users can reveal it. So let's continue to the rest questions. So like this, if we enter a valid option that are not in this 5, then it will show the error message. And loop this for users to enter a valid option. So you can see here, there's a level up message here. We have a interactive system that if the user scored total of 5, then it will show a level up message to a final row, a row that shows climate learner and climate, and if it hits the total of 10, it will upgrade to the role of climate advocate. And if the users got all the questions right, then it will shows the role of eco champion. Then we will continue. So in the end of the quiz, it will show the final score and then the final role of the users. Then this section is to review the incorrect questions. The incorrect questions that the users answered wrongly. There are two wrong answered questions, and it will be revealed here so that so that the users can revise what they have did wrong. And for this message, it shows that the quiz score export to the txt file. So if you view the txt file, this will be the the result that we did just now with the status and then the final score and also with the timestamps where we finish. So the instruction says we can type X anytime to quit. So if users want to quit early, then it can type X to quit. So here we show the message that quiz end early and users didn't got any marks. So as you can see, the status will be early exit because of the users choose to end the quiz earlier. So there will be no marks given to the users and also the timestamps again. So that's all for the first two modules that I'm in charge of. So I'll be passing it to the rest of the modules that are did by Marsha.
So now I will demonstrate the key modules that I'm in charge of, which is carbon footprint calculator that estimates your carbon emission, and an action recommendation that suggests personalized sustainability tips for the users. For the carbon footprint calculator, we have 3 classes here and 1 text file to store your results. The first, we have the main class which runs the calculator. The second class, which is the user input, that handles all user interactions for the calculator to run. And the third is where all calculation logics is stored in. For the user input, it demonstrates where what users should enter in and gets valid input from the user. So now we'll try using the carbon footprint calculator, which is 3. And it will prompt the user to enter their electricity usage, whether in a week or a month, it's up to the user. So now I'll just put a number here, which is 1,200. Next, next, uh, next, a transportation question will be asked for the user, and you can enter one of the transport here, and the distance I'll put 300 km. Diet type, there's also choices here for the user to enter, and I'll enter average. And here they'll ask the user for number of short flights with token in a month, in a year, or it's up to the user. So I'll enter 1. And long distance flight, I'll enter 2. And also they'll ask for the waste materials the user would commonly throw away with choices here. Next, they'll also ask for the number of trash disposed. I'll enter 12 trash bags. And here the results will show here with electricity 912 kilogram carbon dioxide emission. And the total result will appear here. And here after this, they'll ask for whether user would like to get recommendations on reducing carbon footprint. I'll end it here first. This will show it up, and it will loop back to the main menu for the carbon climate app menu. And for the result shown just now above here, the result will appear in the text file. The next module I have is carbon action recommendation. And for action recommendation, I have 3 classes as well. The main class, the recommendation categories, where all recommendation tips is stored in, and the user class, where user interaction happens. So I'll enter 4 for the action recommender, and the categories will show below menu with types of factors that affect the carbon footprint of an individual household. For example, I would like to get electricity usage tips. I'll enter 1, and the tips will display here. And next example, I would like to get tips on diet type. I'll enter 3, which is diet type. Tips will display here. For this module, I also have a random tip generated, which is 6, which user would just like to know for extra from one of the categories, which is 6. And 7 allows user to verify their carbon footprint level. The carbon footprint level I had just now was 2,600. And it shows that my carbon footprint is higher than climate safe level. try using our tips to reduce it. And to quit this action recommender, enter 0 to exit. And the main menu is displayed again. To quit the whole program, user will just have to enter 5 to exit the main program. A thank you message will display here. The carbon footprint calculator would also handle errors when user type in the wrong error. For example, I just type in hello here. It will show invalid input and please add valid please enter a valid number. Until enter a valid number, the system will keep looping until a valid number is entered. So for the transportation tool, invalid input, please enter one of the choices. Same goes for all. That's it. That's it for the main. That's it for the modules I'm in charge of. Exit the main menu, enter 5, and the whole program will exit. Thank you.
Thank you for paying attention to our presentation. That's all for us. Bye-bye.
Thank you.
Thank you.